Good day everyone and welcome back to the channel. So in the last video I made a really long video where I spent a little bit over 3 hours, probably about 3.5 hours. The video was pretty much all of what I did, but there was a little bit of preparation and moving things around that I did off camera. But I covered a lot in that video, but I wanted to still do some more testing and analyzation and stuff like that. I want to come to a really good conclusion as to exactly what's going on. A lot of this will become more apparent why as I get through these videos. So anyway, first thing I decided to do was get a beefy heatsink out of my heatsink pile. This is pretty, when I say beefy, I mean like thick. It's got good thermal mass to it and a good thin area. And more importantly, a spot to mount a transistor right smack bang in the center. First thing I wanted to do was take the piss out of one of these. This is the MJ15033. I'll start off with the 15032, might as well, that'll be the NPN, I guess. Yes, it is. I've got the data sheet up on the computer right now. I'm going to mount this onto here, and then I'm going to set up a couple of power supplies with this. Basically what I want to do is a couple of tests. The first test I want to do is run, oops, that's round. I want to run 8 amps continuous current across the collector and 2 amps in the base. That is the max rating. I want to see how long it holds up like that for. Obviously I'm going to monitor the temperature of the heatsink. I'm probably just going to set up a fan on it at a full speed anyway. I'm still going to have to monitor the temperature, but as long as I can keep the heatsink under a certain temperature, I'll be able to do this. If it starts to warm up considerably, above say 30-40 degrees, to the point that I can start to feel it getting warm, I'll probably, which I guess will happen at that current. It's just going to take a bit of time because of the size of it. So we'll see how we go. Because I'm trying to work out if I'm going to have enough time with all this mass to do the test, or if I'm going to have to, work out the safe operating area at a higher temperature and turn my current down to compensate. But either way, that's what I want to do. I want to push it to its limits and see if it can hold up like that for a little bit. If it can hold up like that for a little bit, it'll be genuine. If it dies really quick, obviously it'll be fake. Now we already know this is fake, so I just want to see what it does for a different reason. We'll get there in a sec. But a lot of the transistors I have to test, some of them I haven't even looked inside. A lot of them I haven't looked inside, so it's going to be quite interesting. The other thing that, and this is what I'm really interested in this video, I wanted to see how much these little miniature dies can actually take mounted, to a bigger heat spreader. I'd be curious because like some of the dies were, when I say decent size, I mean they weren't like TO92 or even a small TO126 die. They were sort of like a large TO126 die or a really small TO220 die. And some of those dies can handle about 5 amps. And it got me thinking, are they getting away with it because they just handle a current, but they just burn out really quick? So people don't realize initially because they work, but then they burn out after a while. Or is it just because people are not ever using them to their full power that they don't know? What is it? So I'm hoping to uncover all these questions and more in this video, basically. So without further ado, I'll get this set up and we'll see what it does. Now, obviously for testing, because the heatsink isn't going to be referenced to anything else at all, I'm not using any sort of, heat insulating, not heat insulator, what I'm trying to say, thermal pad, mica, silicon, anything like that. I'm just putting heatsink compound straight on it very evenly and mounting it straight down to the heatsink. I want to get the best thermal transfer I can get with this, and I'm also hoping that, like I said before, with the thickness of the heatsink and the design of it and the area, if I sit it upside down and put a fan on top of it, it should really efficiently get rid of the heat. The other thing that's going to be really good for me is if the transistor blows up and cracks and a little bit of the black plastic goes flying out, well, if it's facing down, it can't really hit me in the eye or something like that. So let's hope. Now, I just want to say, if anyone can hear music or people screaming and singing and stuff like that, my neighbours have been doing a lot of partying lately. There's nothing I can do about it, but yeah, my apologies if any of that comes over on camera. Alright, I'll finish setting this up off camera and we'll see what it does. I don't know if you guys can hear that or not, but it is 10 o'clock at night. I'm in my lab and this is all I can hear coming in the window. Just ridiculous. You can probably hear that just where the phone is there, I guess. My apologies. I waited for them to stop to start recording and they've started again. It's just... Alright, I'm just trying to get the power supply and the transistor in view. It's mighty hard, I can assure you. Alright, there we go. That's going to suffice. So I've got one channel on the base emitter junction and the other channel on the collector emitter junction, and I was going to turn it over, but I figured it's going to be more fun if you guys can see that. So I'm just going to, because the first test I want to do, I just want to put full power through it, obviously not for a really long period of time because it's not really being actively cooled and it's facing up. I just want to test basically how thick the bond wires are and the actual size of the die. If it's way too small, it's just going to die straight away. So let's see. I mean, we know how small this one is, so this is definitely going to be funny. It could be funny in multiple ways, but it might actually fail, you know, at a higher current than what we're expecting for the size of it. I mean, I don't know if you guys remember. I'll show you after we've destroyed it how big the die is. It's pretty funny. Considering this is a 2 amp base, 8 amp collector emitter, 50 watt part, 250 volt, it's a chunky part, you know? Alright, so I haven't really decided on what I'm going to do here. I think I'll put 10 volts across the collector emitter. Yep. And I'm just going to give it current, basically unlimited on the 10 volt side, and just control its consumption through the base. I'm not really worried if this power supply gets hurt either, you know, from transistors shorting on it, and yeah, it's all good. I'll either fix it or get another one. It's cheap as crap. It's not one of the good ones. That's what this is for. This is for abuseful tests. I still do plan on improving this power supply, but it's still the cheap one, you know. Here goes. I'll start here. Oh, I've got my voltage turned down. My apologies. Actually, I'll just leave the fine turned up because that goes up to about 3.3 volts, which will be plenty. That's 1 amp on the base. I'm honestly surprised it's taking this. Oh no, that's 1 volt on the base. I was looking at the wrong screen. Yeah, this is going to fail any sec, I reckon. Wow. I didn't even expect it to get here, to be honest with you. No way. Oh, There it goes. Wait, what? That transistor just popped, but it's still working. No. No way. Surely not. How on earth? I don't know if you heard that little crack or not. I can't seem to get it past what it's at. Yeah, it won't go past 5.2 amps, so it must be limited by the resistance. Ah, it's failed. There we go. I don't understand how that took that much current. I'm not going to lie, I don't have any experience doing destructive testing on transistors. In fact, I'm going to do a little bit more reading before we continue, because I find that odd. There's no way that's the correct die size in there. I'll show you guys again what it is. Let's go back over to our usual spot. Alright, I'm just going to do it here, because I've got my phone plugged in and I don't want to have to keep unplugging it. I'll just get some pliers. Because the die in this is so small, there's no way that's the correct die. We all know what the die should look like for a part with that much power consumption. So I just had to wipe the heatsink compound off of that. That was just annoying. And I do appreciate that people probably can't tell how big that die is, so I'll measure it. It's a millimeter. 1 millimeter square. Yeah, I can't see any way how that could possibly be the correct die. I could be wrong, but I don't think so. I think we're uncovering some really shady business going on here. If you've had any experience pulling transistors apart, leave it down in the comment section what you think, because look, I've got to be honest with one thing. I am used to what older transistors look like, right? And to my knowledge, silicon processors do get smaller over the years. I don't know that would mean transistor dies so much though, especially in terms of the width and height of the die, because you've got to dissipate power, right? So yeah, bit interesting that. I am still shocked that part made it up to 5.2 amps on the... Oh, I just realised that power supply only does 5 amps. Well, it failed anyway, and it never got hot because I kept feeling it and it was still cold, so obviously that was fake. You know what, I didn't think about that. I'm going to move to the other power supply. Sorry about that. That was my bad. Good thing the transistor failed, otherwise we would have had to do the test twice. I'll put one of the tip series transistors on there now. Alright, I've got a tip 41C here. There's enough thermal compound on there. If I move it around a bit, it's evenly spread. Alright, I'll just get a setup for a different power supply and I'll get the data sheet ready. Alright, I'm back, still at the same power supply because honestly I just realised something else that's funny. None of these transistors are going to handle 10 amps. And if one does, then alright, we'll move over. Tip 41C. This has got base current maximum of 3 amps, collector current 6 amps. So let's see. Oh, it's got a lot more gain on it. Oh, maybe that other one did get hot quicker than I thought. I can feel the heat. I didn't think I touched it quick enough before. Let me press down on it. That heatsink does a good job, but I'm not going to lie. I'll put it like this because heat rises. That's obviously a lot better. Let's just go. I don't understand how these transistors are holding up. This is starting to explain how people... That's cold. Oh, you know why? The die's so freaking small. It would have the worst thermal coupling to the case and to the thing. We're allowed 3 amps in the base, 6 amps on the collector. I'm honestly shocked with how small the dies are in these that they can even do this. Quite amazing. The Chinese are up to something. I'm telling you, we've got to investigate this. This doesn't make sense. There's no way transistor dies can be this freaking small, and what the hell? How is this still... I mean, even the collector emitter current I can sort of believe, but how on earth is the base handling 3 amps? I just can't believe that. That is amazing. You know what? That makes no sense at all. By now this heatsink should be a little bit warm. There's no warmth here. That was 50 watts I just put through it. That should have, not including the base current, that was 50 watts. Wow. Okay, it is getting hot, but I mean, yeah, okay, that is getting quite hot. So that is ridiculously hot. That should have popped. The temperature that that little die would be at right now, I mean, blistering hot. And it still hasn't shorted. I don't understand that. The Chinese are up to something, I'm telling you. They've somehow worked out how to make transistor dies. I don't know, there must be different transistor die technologies. There must be dies that are smaller and cheap to make that handle more current than what your average dies handle. I mean, I've shown you guys inside an actual genuine tip 41 series transistor, and I've shown you inside this here. You've seen the die size difference. It's not a little bit smaller, it's a lot smaller. How the fuck is this still going? And it's just not coupling any heat out. You'd think it died. No, alligator clip fell off. Yeah, I can't get my head around this. That transistor is so freaking hot. Let's move to the other power supply. I'll use this for my base current still, and I'll just move this over so that I can supply more current. I'll just pause the video for a second, run some cables over here. Alright, so this is what I've done. I've set this one up with a compliance voltage of 10 volts and current limit of 8 amps. Barely focuses, but you can see that. If I put this here, look up, yes, you can see both supplies, and I can just put this on the table if I can get these cables out the way. I don't need that much space, just a little bit. Oh, one of my crocker clips is buggered up. That's why I'm having trouble getting this on. Right, that's better. Alright. So, this is your amp draw across the collector emitter. What I've got over here is the base. So I'll come over here and wind this one up. I'm just going to go straight to 3 amps. Well, actually, no, we'll go straight to 8 amps. That's, yeah, what am I saying? That's 8 amps. Wow, that is going down fast. That's the small die. Alright, I can't... Whoops. I got to get a better controlled method of doing that. That was funny. That was real funny. I just popped that, but again, it's like it didn't pop. What the hell? No. It's still working as a transistor. This is weird. These things are literally popping and letting the smoke out. You saw the smoke come out of that, didn't you? I did. If you didn't, pause the video and go back. You'll see a puff of smoke come out. Let me think about this. What can I do? I'll set a compliance voltage here of 10 volts. Alright? Because I was set at 3.3 before. I wasn't putting any thought into that, which is kind of silly of me. And then I ran out of base current and I realised my compliance voltage was too low, and then I tried to adjust it mid-test, and well, we all saw where that went. Let's see what happened to this. So it shut out the emitter leg. Has anyone ever seen a transistor take a shit? Let me show you. Transistor took a shit. Out the emitter, where it's supposed to be. Pixies in the collector, shit out the emitter. Alright, well, let's keep going. I don't know how that's still a working junction in there. I guess because they're fake, that glue and stuff that's in there that's all mounted down to is probably what's failing first. And the silicon die is actually still working somehow. I don't know how the bond wires haven't broken, but this truly is a mystery. Alright, I'm going to go take it up to 8 amps on the big supply. Oh. Straight away. So that's interesting. It seems... I'm going to have to... Now I've got the higher compliance voltage, I'm going to have to watch the... Oh God, the base current. Wait, what? No. Are you seeing this? This is still behaving as a freaking transistor. Just for shits and gigs. I'm just going to unplug that and unplug that because I do not want to destroy my... This is insane. The plastic's cracked now on top and there's liquid coming through it. Melted glue. I don't know what to say. 125 gain still. This is honestly the funniest shit ever. I never expected this. That is absolutely insane that is not shorted yet and the junction still works and it still has gain and everything. That's now exploded twice. 2 lots of smoke have come out of this transistor. The top of it now looks like this. I mean, seriously, and it's still working. I'm not trying to give the Chinese any credit. Please don't buy these. These are rubbish. Okay, I'm just gonna... What? Oh, what, now you die? No? No, it's not dead yet. It's just acting strange. I'm going to turn that off and put the peak on it again. This is the weirdest shit I've seen in my life. I'm a man who has blown a lot of transistors in my life, and I can tell you now, I've had chips come flying out of them, smoke clouds come out and everything, but I've never had a transistor blow up 3 times and still somehow behave somewhat like a transistor even after completely... Oh no. Oh my god. Did I just fucking do that? Yep. I think I just killed my peak tester, guys. Well, it says low battery now. I think it's dead. I can't believe I just did that. Oh, well, let's find out. Why not? I'm sure you guys are as curious as me. Oh, fuck, I can't believe I did that. My apologies for swearing, but this thing cost $250 and I just freaking hooked it up to a transistor without unplugging the power supply first. Like, you can't get dumber than that. Man, if I killed this... Ah, man. I'm just having a look at the circuitry that does the lifting. You know, it's possible that even if I did fuck it, I could fix it. I'm going to stop swearing now because that's not good for YouTube, but oh man. Let's just hope that I didn't, and that was just those leads moving around that did something on there. I don't think so, however. I think that was current getting reversed through these little transistors that switch. I don't know what I'm doing. That just messed up my head. Alright, I just had a quick look and this BAV99 diode was shorted. There's a whole load of diodes across the inputs here. I'm guessing for protection. There is a chance that that diode shorted before something else shorted and it saved it. So I've got BAV99s. Let's change it. Actually, let's make sure that is what's shorted first, because it might not be shorted. It could be something else on the board, or it could just be that those pads are supposed to be connected together. I certainly don't know. I don't have a schematic for this. But in circuit, it was... Oh, damn it. Let's just go straight to the board and save mucking around there. Nah, the short's still on there, unfortunately. And that is, how do I say, I'd say? Where's ground? Yep. Oh. That might, oh no, that's not supposed to be like that. So I've blown 2 of these 3 chips. The last one seems okay. Oh, wonderful. Wonderful, wonderful. And I don't have these. No, I don't. DG442LEDY. Don't even have a clue what they are. I've got CD4051s. If that chip went out, I could just swap that straight over. Oh well. Oh, God. And honestly, in my experiences, I could just order the chips and replace them, but you can come a guts are there, because if I've popped them and I've popped something else further down, I can spend money to replace those, you know, only to find out that they're still more broken. So I'm just going to put this in the drawer for spare parts and just buy another one, you know, and then at least I've got a spare micro and firmware and all that sort of stuff, spare screen, you know, buttons, whatever, for the new one that I get. You know, if you know a better solution to sorting this problem out, like you've repaired one of these before, or you know somewhere that fixes them really cheap or something, leave it in the comments. But I'm honestly not too fussed. It's not the end of the world for me. It's a bit annoying. They're a bit pricey, but it's just money. It comes and goes. It is what it is. Goodness. I just can't believe I did that. It's because I'm freaking pissed off because there's these bloody neighbours with their fucking music. And I'll tell you why I'm pissed off, because if I play music, the police come and rip my fucking speakers out and confiscate them. But these guys, you know, 10:44 at night time, can be pumping music and screaming outside, and no, it's fine. Just do it for hours. Don't take their speakers. Don't even tell them to shut up. But if I play 2 songs, I'm not kidding you, the coppers, after 2 songs, will come around, give me a noise abatement. And then if I then breach that noise abatement by, say, playing 1 song on a following day, they will literally remove, you know, I'm not kidding. I mean, I've had like 6 tower speakers, 2 12-inch subs, 3 amps, an EQ, my computer, my TV, the whole lot ripped out my living room. I don't have a system set up like that in there at the moment, but I plan on doing it again soon. And I'll tell you what, this shit better not happen, because if they're going to let these people do this, they're going to let me have my fun for 5 or 10 minutes. This is just ridiculous. It's been going on for like 3 or 4 hours, and I can't, like I said, I can't have fun for 10 minutes. Alright, let's go back to having fun and not worry about this. Good thing I wasn't planning on using that for this video. I'm actually waiting on that, what's it called? The DYE, whatever it is, that new transistor tester. I'm actually waiting on that. I forgot to put that back. Oh God. I'm actually waiting for that new transistor tester to arrive so that we can do some more in-depth testing. I was planning on using that in conjunction with this. I'll try and get one of these quickly before that video. It just depends. If someone's got these in stock in Australia and they're not going to charge more than what I paid for this, well, obviously I'll just do that. But yeah, who knows. I'm just going to bodgy this in with iron, seeing as I've destroyed it. I'm not really too concerned about it anymore. Just keep its original parts in it. That's the only reason I'm putting this back in, just so that when I put this in the drawer, all the original parts are in it. That is electrically connected too, so you know, if I do go to fix this and I forget about that BAV99 diode, yeah, at least it'll be in circuit until I notice it one day changing the battery and do I need a job. But like I said, I'm pretty sure this is just going to become spare parts. don't worry, I'm not one to cry over these little things. It's all good. Like I said, it's just money. It comes, it goes. Then it comes again. Then it goes again. Alright, let's go back to what we were doing. I was just thinking about it. Maybe I should order those chips. You know, half my logic says to me, you know, nothing else is probably fried further up because those are the chips that do the interfacing with the outside world. The other half of me says, it now says low battery with no low battery. What's that about? You know, it worries me that something's wrong with the micro or something else. I don't know. Like I said, if one of you guys has gone through this before and you know the answer to this, leave it down there for me, please. Anyway, let's continue having our destructive fun here. See if this transistor still functions. Yeah, somehow that's still doing something. Not very much. Wow. So, check this out. If I turn that off, I can pass 10 volts, no current, maybe like 1 milliamp into the base, and that still passes current through the collector emitter junction somehow. That's absurd. Hold on a sec. Is something else going on here? Is that just... maybe it's something to do with my power supplies. No, it's not. Must be some of the carbon in there is turned to a resistor, and when I'm turning one supply on, it's shorting into the other through said carbon resistor, because there's no way that die could still be doing something in there. I can't believe it. Anyway, that was very strange. I don't know what to say about this. And the thing is, whilst, like I said before, I could understand that some dies might be smaller nowadays because we make smaller silicon with advancing technology. PIP 41s are old transistors, right? They're not... This isn't a new part, so there's no reason why the die should be all microscopically small inside it. I still can't understand that applying for power devices anyway, but... Alright. I will go get another transistor and we'll do the same thing. Alright, you guys are probably as curious as me. I just had another quick look, and these ICs are digital switches, which means I've most certainly fried something else the other side of them as well. So I'm just going to put this in the drawer for parts and grab another one. Alright, back over this side for a minute. So these are more devices that I bought, but these I never bought advertised as original. They were just sold as BD 135, 136, 139, 140. I'll just give them a wipe and lay them in my hands and give you guys a look at the front of them. You'll notice the same exact stuff that I showed in the last video. I hope that by now everyone's starting to learn what to look for with this. I'm sorry that doesn't want to come across any clearer. But they all say the same thing. NXP54. That makes me laugh. Seriously, come on. How the hell do they think that by putting the same shit on every single device, people are going to be like, oh yeah, they're real? Like, really? Or don't tell me people that dumb enough to think, oh, like they must be buying in such incredible bulk or something. Like, what? Come on. Wake up. Oh, that's hilarious. That is so funny. This is a 1.5 amp part. Can you see the die? Jeez. I reckon a 500 milliamp TO92 die is probably bigger than that. That's insane. What was that? 140. Let's see if these are all the same or different, because that'll be interesting. Looks the same to me. Oh, that's the 139. Well, it should be the same. Actually, yeah, no, they're the same. All right, 135 and 136. Yeah, these are getting flogged off ridiculously cheap. I mean, you can get 10, 20 for a couple of dollars, like $1.60, $2. Like it's obvious, but at the same time, I still don't understand how these are actually handling the current, even if it's for 10 minutes. Like, I just can't believe that. The fake market's really going to the next level now. Because it used to be that you used to just power them up and they used to pop straight away like that. You know? Now they're actually working, and like what prompted me to do this extra testing today was I've been Googling a lot, and people were like, no, they work, they're fine, and I'm just like, what? And last time I did a bit of research on this subject, all I could find was people like, yeah, I put them in this or that, turned it on, it went up in smoke straight away. Now they seem to be handling amps of current. That just blows my mind. It's like maybe they just had to deal with so many refunds and stuff that they sort of worked out how to fake them a little bit better. I don't know. They're certainly terrible transistors with terrible properties, that's for sure. I don't know why people think they're good, but all right, well, I'm going to put I guess it doesn't really matter. I'll just put a BD139 on the heatsink and we'll see what that does. I just did a little bit of math, and I'm even more concerned because if I basically turned my voltage down and did this test not from the focus of current, but power dissipation, I would be running less base current and probably less collector emitter current into the transistor. Now, if this part held up over the power dissipation that it's supposed to do, it would definitely hold up under it, which really scares the crap out of me because the die is like, I don't know, a fifth of what it should be. And the Chinese are now getting away with this crap to the point that they're sort of holding up, dare I say it. Like, this is just really not good. All right, let's do the same thing again. This is 0.5 amp on the base and 1.5 amps on the collector, so I'm going to have to be a little bit more careful. Whoopsie. That went really quick. Oh, that was funny. I don't even know what I did then. I'm going to have to turn everything down quite a lot. This is funny. Wow. Wow. Did you see the dye glow red hot through that? I hope you did. If you didn't, rewind and have a look right there. That was really cool. Alright, I'll reset this up and I won't be so stupid with the controls. Got to be a lot more careful with these small parts. You can't just, you know. Although, I won't lie, if it wasn't a fake, it probably wouldn't have had any problems with that whatsoever. I'll just go get another test subject. Alright, let's start again. I've set current limit at 1.5 amps for the collector emitter junction. Still 10 volts. I've turned the voltage down on this. Now it's at 3.3 volts and I'll slowly wind up the current. Wait, what? Huh. These ones are really bad. that just died straight away. Huh. Okay. Not quite sure what to make of that. These are really bad. I mean, I wasn't abusing that in any way. That's crazy. I mean, wow. So some of them handle an insane beating and others don't handle anything at all. That doesn't make any sense, man. I can't understand how they're getting any of these little dies to work at all. And then why on earth, if you can make some little dies run so hard, why would you put crap ones that don't work in other devices? I don't know, this is really odd. Let's get back over there and I'll get the next transistor I want to have a look at. Alright, now these ones are interesting because I got a batch of these, the 2SD882s. I got a batch off eBay a couple of years ago. I already owned some, I can't even remember where I got them from. Then I got some factory floor sweepings I bought and I rounded up a whole load out of that pile. And then I also bought a couple of clone kits off AliExpress that had some in it. And do you know what's really funny? They all look exactly the same, apart from when you look at the front of them. It can take a while of going through this to find the different ones. There are slightly different markings on a lot of them. Alright, I've found 3 examples. This will do for now. I'm not going to sit here and go through the whole pile, but you'll probably notice that it says PM95. That's a really common one. I find that on a lot of devices, PM95. But anyway, they're D882s, supposed to be D882s. Scary thing about this is I've used them and they freaking hold up. That's its partner, the 772. I've only got 1 or 2 batches of those, and I don't know how well they work or don't work because I haven't used the 772s. I've just used the NPN one, the 882. So the 772's got the smallest little die in it. Sorry guys, I just realised where I was holding that. So very small again. That's, you know, that's not even a 1/2 mil die. Let's see if these are the same. And are they the same as each other? Because that's something else I want to know. Not just what they like, but the consistency between batches. I've got a feeling that they might be quite different, but who knows? We'll find out soon. Oh, I was really right there. So, wowee. That is absolutely amazing. So, we're really uncovering more secrets every video here. This is amazing. This one doesn't have a die in it whatsoever. What the hell? No die whatsoever. Minuscule die. That's a good sized die for a D882. I wouldn't be surprised if this was a legit device. That might explain why I was using them and they were working. Let's just these are all PM95, aren't they? What was the working one? I mean the big one. M2Y. That's what I've grabbed here. And it looks like I don't have many of them at all. But there are some other ones in here. Oh. That I've taken off of a circuit board, and that's actually completely different. I would say that that's an original one. Ah, yes, that's not magnetic either. Okay, cool. I'm willing to sacrifice this so that we can have a look at what the die is supposed to look like, because I would wager bet that, where is it? This one, that's the correct die size. And they're just putting these little specks in the clones instead. Let's leave that aside for a sec. Let's keep pulling these apart and see what the consistency is like. That one that says 2Y, I'm not going to destroy it because I know what the size of the die is in there. It's what it should be. Just a little speck. Same batch, they're all the same. What differences can we see? Quite a lot. So in the little circles on the plastic, there's actually writing in them on the real one. I'll bring it up to the camera in a sec. I'm curious for my own eyes. Sorry. They're getting good, I'm telling you. They're freaking getting good at this, which is scary. Just not perfect. All right. Seems like a shame to do this. I hate ruining good parts. I freaking hate it. I'm starting to see heaps of these 2Y models now. Here's another one, PM09. This one just says 882 with nothing on it. 2Y. 1Y. Okay. Geez, I do have quite a few batches in here. I'll just bring these up to the camera for reference. See, PM09. The font's different on all of them. One of them doesn't even have a brand. Let's have a look at the one that's got no brand on it first and see what's inside that, eh? Still, yep. Oh, wow. That had what I would say is the correct die. And it's interesting that two that I've opened now that I thought were legit, the die is completely gold on the back of the die, not silver. I think they're real. That means I've got real transistors mixed in with fakes here. This is annoying. 1Y, M1Y, NEC. I don't know what to do. PM09. Wow. PM09 was real as well. Maybe even a slightly bigger die than those ones. They're good devices. Wow. What about 1Y? So what are these fake ones? All the PM95 are the fake. PM95, okay. Yep, real. I'm keeping the real ones off to the side because I've got to go through this obviously and get rid of all the fakes. These 772s, let's see. Maybe there is something else in here. Oh yeah. So we've got this PM Got some 2Ys, PM95, M3Y, a lot of M3Y in here. I think, yeah, the last of it's all M3Y back. So take those couple apart. One's a Y2, one's a M3Y, one's a PM95, but these are all 772s. So starting with the PM95, because we know that's going to be fake. And what do you know? Minuscule die that you can barely see. So this is MY2, and I suspect that could be real. Did we get any with small dies that were not PM95 yet? Alright, my phone's been overheating because the battery's flat and I'm trying to charge it at the same time as recording, and I don't know why, but it just makes it overheat when I do that. So let's try and get this done. So I was just having a bit of a look at these. It looks like this one's got a slightly bigger die than this one, but I'm content with that die size. Like I said, I know my dies pretty well. Not just that, I know what the exact size of certain dies are, like the MJE15032. I know exactly how big that die is supposed to look. It looks very similar to a tip 41 die, which I showed you in the last video. So I'm not taking guesses here with a lot of these transistors, and with the ones I am taking guesses, they're basically the same power handling and power dissipation, should I say, as the ones I do know. So it's kind of easy for me to work out looking at this. And I have to say, that is the right size for this transistor. I mean, we'll pull this apart soon and I'll show you anyway. But, yeah. We'll have a look at all the cases afterwards and I'll show you what fronts have got the little speck in them and what fronts have got the big die in them, you know what I mean? Like I said last video, I want to uncover all of this. Not just for me, for everyone. I want these couple of videos to be able to answer all the questions as to what's coming out of China, what the clones are like, how they perform. So that's what the last video in this series is going to be about the most, is we're going to do a lot of different curve plots and some testing at higher currents with that other tester that's coming. Might even do some circuit testing, like with the scope and a signal generator, stuff like that. Who knows? But I really want to, you know, go into this in detail. Because the thing that, I don't know if you guys are getting what I'm saying here, but the reason I'm really concerned about this is the fact that some of these really small dies, as you saw, are handling the power. That isn't right. That is really scary, because that means for a long time now, it's been really easy to catch these transistors out, because as soon as you put them in a circuit and turn it on, they just go pop. Well, if they're not doing that now, or at least not straight away, that explains how they're getting away with selling so many. All right, I'm going to do this for YouTube, because I don't need to do this myself. I know what's in here. But just to prove to you guys that that's maybe a little bit small, but those ones are definitely the right size, I'm going to open this. And there you have it. So yeah, that is a tad smaller, that one, and the ones that are a little bit bigger are the correct size. But Just ignore the color difference. That die is split in half. That's perfectly peeled off the back. But yeah, there you have it. So I guess these are clones, or I don't know, it could just be a newer version. I have seen transistors that have had multiple releases over a lot of years. Tip 41s are actually one, surprisingly. So yeah, that does happen, but it doesn't usually get visibly smaller in terms of the die. So yeah, I would say that that's still a copy. A usable copy, but you know, it's not very good. It's certainly smaller. All right, well, that's that. I'm just going to go and empty this into the bin. Hold on, actually, what am I saying? Let me show you guys what's going on. So on the left here, we've got specs and one case with nothing at all. I'll just put that off to the side because there's nothing in it. No, I'll leave it up here because I want to show you guys. So these are the ones that work or actually have the correct die in them. Some of them are just a tad smaller, some of them are correct. But so I got to unlock my camera. There you go. All right. Two of them are a little bit smaller, but they're not concerningly smaller. Now, just for comparison, here's one of the smaller dies that's not like ridiculously small. And look how small those other dies are compared to that. So, yeah, it's kind of ridiculous. So we've got PM95, 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 M3Y, PM95, PM95, plain D882P, B772P, this is MY2, PM09, M3Y, alright, M1Y, genuine one, PM9X, M2Y, and the couple that was slightly too small are M2Y, the plain packaged one, MY2, and PM09. So it's literally pot luck. As you can see, it is pot luck whether you get the correct size die, one that's just a little bit smaller, or one that's so small it's going to pop in a second and you can't use it. Now, here's the next problem with this. Even if you can use it because it's the right size, it doesn't mean that any of the properties of the transistor are anywhere near the properties of the transistor that you're trying to use this for. Now, that's the biggest part of the problem here. China. Alright, I've been doing some thinking about this. That concludes the video on that. I'm not going to do any more destructive testing or pulling apart transistors. We've seen enough. I might actually, after we've looked at this, I'll pull apart. I'll grab them now so I don't forget. I read on a forum, and obviously what you get on a forum, take it with a grain of salt. But anyway, some people are saying that they put tip 31 and tip 32 dies in everything, the clones. This is TO220 power devices that we're talking about. So apparently, like all your MJ15032s and 33s and tip 41s and tip 42s and your more powerful TO220 devices, they just put tip 32 dies in. Now, I don't know if this is true or not, but I've got some tip 32s here and tip 31s. These are the same dodgy, they came out those kits that all these clones came out of. So what I'm curious to see is that the same size die that's in the tip 41s and tip 42s? Just curious, you know? Also, why not, we'll get a look at the data sheet for, say, like a tip 127 or one of the other Darlington tip series, and I'll choose one of the higher power packages and we'll pull one of those apart too. I just want to know. Anyway, I've been thinking about what I'm going to do about this, and I was literally actually putting my shoes on to go up the bank, put money in the bank and buy another one. And I thought about it and I thought, you know what? I've got this new transistor tester coming. It's going to be here probably in a few days. I'm pretty sure you can do HFE on that. Well, you can. So obviously you can measure VB in a bunch of different ways. So I don't need this right now. I mean, yeah, I do want to be plotting curves and stuff. Actually, that's something that we're going to be looking into soon, is a bit of a surprise for you guys. One of the things I want to do on this amp is experiment with transistors, mixing them. So putting a whole load of well-known, highly good linear devices on the tracer, tracing them, and then basically taking NPNs and PNPs from whatever two different devices and putting them together to create an even better matched pair than what you get with a matched pair like tip 31, tip 32, for example. That's something I wanted to do, and that's going to take this. So I do need one of these soon, but anyway. I was thinking I might just have a crack at changing these three ICs. I do need to work out what they switch through to, and I think I've just answered that question, because I can see three lines coming out here going to three 1K resistors that go into a CD 4051. Oh, it's a 4051, not a 4053. Now, that's a it's some sort of gate. I can't think. Let me see if I've got a data sheet on my computer. Oh, I might actually be screwed. This is a multiplexer, a single 8-channel analog multiplexer, demultiplexer IC. It's essentially a switch, another switch. So that must go into a micro. That's not good. We've got an HC494AG. We've got an MCP6H04. I'm not sure what that's doing. That could be for the screen. Although, no, that main microchip part's probably doing that, actually. I can't see. Oh. Yeah, no, I can't see. It could be this that's driving the screen. I've got a bad feeling that just due to the nature of how these things work, I've probably screwed quite a lot up it. I basically just threw angry pixies up here and they would have just gone bang. You know what I mean? I think I'm going to have to order another one. I'll do a bit of research on it. Like I said, if anyone knows, anyone's owned one of these that, you know, does electronics and has repaired one, and you know what would have happened, how far the current would have flowed from here back into the circuitry, because I'm not sure. I mean, obviously it's going to make its way through them and that, but I'm not sure Does it then go to the main micro? Does it go to an off-the-shelf part like this that I can change? I don't know. And the sad thing about something like this is, you know, unless a transistor or something like that's broken, there's essentially no way for me to work out what's wrong with it and fix it, you know, without blindly swapping ICs. And to tell you the truth, I've got enough things already that I've got to fix that are going to be those kinds of jobs, so I don't need any more. Yeah. Oh well. I'll do some research off camera, and you know, I'll do my best. If I think it's fixable, I work out that I might be able to repair it, you know, I'll order the parts. Otherwise I'll just have to get a little bit of work, wait a bit and order another one. So be it. Is what it is. I just wish I was more relaxed and not so agitated over my neighbour's music. Maybe I wouldn't have done that, because the first time I went to stick this on the transistor, I turned the power supply off, but then when the music started playing again at like 11 o'clock at night, I couldn't hear myself in here, and I started to get a bit shitty, and then I did this. Oh. Alright, well, let's have a look at these tip 31s and 32s and I'll end the video. Alright, what have we got here? These came out of different factories. Yeah. Yeah, they came out of different factories. Alright. G'day, little man. Now, I'm going to have to get a data sheet up for one of these because I can't remember what they're rated for. Oh, wow, that is the same die. You know what? I wonder if everything under the tip 31 has got the tip 31 die in it, and everything over it's got tip 31 die in a TO220 range. That'd be really funny, wouldn't it? That is exactly the same. Wow. I won't be surprised if that's actually alright for what a tip 31 is. It might actually be tip 31 die, who knows? I mean, that's what someone said on the forum, which is quite interesting. I don't know how they got that information, if it's a guess, if they've just been looking inside transistors and they think it looks like one. Who knows? Wow, I didn't damage that at all. You gotta be shitting me. That's hilarious. That's really funny. There's still two junctions there. I entertain myself too easily. Alright, let's see what the size is like in this one. Yeah, exactly the same. Wow. I think these are from two different factories. So this is quite interesting to me. Let me just get a data sheet up and we'll see what a tip 31 is supposed to be rated for. Let me just also grab a tip 41 or 42. I'm not really fussed which one it is because they're all fake. Yep. No way. Are they for real? No, that die is bigger. What the fuck? You gotta be shitting me. They actually use different dyes. They put a slightly bigger die in the tip 41. You've got to be kidding me. And it works? That's crazy, man. I don't know what to make of this. This is just boggling. I mean, you've seen the results. These handle a ridiculous amount of power with a die that's half the size. And we know that they're fake. We'd never use them. But people are buying them and using them. And they think they're good parts. That's really worrying me. I wonder how long it is before they start showing up in equipment. I'm sure some manufacturers out there want to get a cheap deal, and and repair shops and small companies. Tip 127. I'm going to get a couple more Darlingtons. Get a tip 137. I've got tip 142 and 147 as well. I'm not sure what they are. And I just blew up my tester, so I can't stick it on that right now. Leave those for another day. I'll just have a look at the tip 137 and the tip 127. And I'll go get data sheets. The interesting thing about these, I did testing on them and I can actually measure the base to emitter resistor, or the two base to emitter resistors between the base and emitter, like the combined resistance, and it adds up to the data sheet values. And it's different between each transistor too. I'll just show you. That's what I'm saying, like these fakes, they're really going too far with them. 8K, this will be 7.5, I think. 5.3, that's right, yeah. It's crazy. Like, what on earth are they doing? How on earth are they getting dies that small to run like a die that's twice as big? I'm not saying it does, its characteristics are going to be completely shot, and obviously it's going to fail really soon. But just the fact that it's lasting even for a week at full power is just, it doesn't make sense to me. And my phone is overheating again. You know what? I'm just going to leave this video here. I've got more to do on this topic. I'll do this in the next video. I'll wait until I get my tester, of course, and the new tester, and then we'll do part 3. Alright, sorry about that. My phone overheated again. Let's take a look at these. I was going to put them back, but I don't want to keep anyone hanging. So I'll start off with the tip 127. Same shit again. Yep. Same shit. More solid than they look. These are the ones with those same fake logos on them that my LM70A, whatever they were, the regulators that were dodgy, had. And there you go. The same little minuscule die again. I hope everyone's starting to see a pattern with all this crap. I really, really hope this helps people. Because surprisingly, it only cost me about 40 bucks for, no, 20 bucks for 2, yeah, 40. 60, no, 60. Because I bought a couple of TO220 kits, a couple of TO126 kits, and a couple of TO92 kits. And then I bought 2 batches of 10 or 20, like 20 or up, 10 of each PNP and NPN with those fake tips and the MJE series. I have bought other transistors too that I purchased at like another time, but I'm talking about the last time I bought a batch of transistors off AliExpress. That's how much I wasted basically on what's happened in this and the last video and the video coming up. Anyway, I hope that this is not only informative but fun to watch. Alright, due to my neighbours partying and my phone overheating, I don't know if you could tell from the tone in my voice, I was about to end the video. But he's shut up and my phone's got a little bit of charge in it now, so I'm going to give it another go. I realised what happened with these, why they failed so quick. Not just because they're a fake part with a really small die, but these are only a 12.5 watt part, and I had my voltage turned up even after I turned the current down, which means the power dissipation would have still been way over what it could handle. So just for the fun of it, I'm going to run this test again. Because this part is low current and a small part on such a large heatsink, I'm going to turn this over. I'm going to put a fan on it. This has got the smallest die I've seen in all the TO126 and TO220 packages. They're smaller in TO92s, but I haven't seen a smaller clone die than that. So let's see what it can do. And then let's do the same thing with a tip 41 with that small die. I just want to see how long it can hold up with full current. And in the meantime, whilst I'm doing that, I decided also to do in this video is to take a look at these guys. The reason I want to do it in this video is because the next video is going to be quite packed with testing and stuff like that with different bits of equipment. And I also have TO92s still to investigate further than just what I did in the last video. So if we don't get a look inside these, it's going to end up, it might already end up being a 4-part series, who knows, because I want to do a lot of testing on all this stuff. Now, here's something I didn't go over too much in the last video, but I want to show you guys this. Let's just grab 3 samples from the first drawer. I'm just going to have to take my focus lock off, sorry. I know what you're thinking, they look really real, don't they? Yeah, I know. And you know what? They could be. Oops. Because these aren't really big, powerful devices, so, you know, there are, here's the thing, all right? This is why I'm doing these videos. I understand that not all of you know everything about this, and neither do I. But over the last couple of years, I have bought quite a bit of stuff online, and let's just say I've noticed a lot of different trends, and it's gotten to the point I've noticed too much stuff, so I thought I'd do some videos on it. However, there are real Chinese factories that get leaked information and make clones of stuff, and they're perfectly fine stuff. There's nothing wrong with them. They work well. Sometimes they even surpass in specs what the original device did, which in my opinion isn't a good thing, because, you know, a device should meet its specs, not exceed it, because it makes it tricky designing stuff. If you get a part and let's say it's got a higher FT than what it's supposed to, you know, that can cause oscillation problems, for example. Like, a lot of things can happen when you don't keep things how they should be. But anyway, let's take a look inside them and see what we can see. I'll just set this up in the meantime. I've set this back up. So what I'll do is I'll put my compliance voltage at I'll put 1.2. This is for base current. 1.2 volts is plenty for the base. And then, I can just dial my current up really slowly. And over here, well, let's think about this. 12.5 watts, 1.5 amps. That's going to be not many volts. Like 5 times 1.5 is what, 7.5, 6, 7, about 7.5 volts, something like that. Let's put 7 volts. You know what? I'll do this on a calculator. My maths is terrible. I want to know. Let's do this properly. All right, 8.3 volts times 1.5 amps is 12.45 watts. So that's what I'm going to do. I'll set that up now and I'll be back in a sec. It was wonderful. I just did a whole bunch of talking and then realized I forgot to start the video again. But anyhow, now I've got good control of this. I've done some testing on this to work out where the limits are. That I've already set that right, how we set it before. I'm just talking about this. I've set it now so that if I wind the current up so that that's on, the voltage is limited right at the top of where it will turn up to. And the current also. Well, that's interesting. I wasn't able to turn it up that high a second ago. So it's breaking down. Yeah, that's real interesting. So it wouldn't go up past 56 milliamps before. Actually, now I think about it, that could have just been the voltage limit. But if I turn the voltage up more, it won't. Oh yeah, it will. Okay, good. Let's see if it takes to half an amp on the base. Alright, that's half an amp on the base. 1.5 amps on the collector emitter junction. Oh, that is getting so hot. That's ridiculous. Yeah, that is indicative of a die being too small because you see, we're not dissipating power at the moment on this device. That is all getting dropped on that little base junction. You can tell by how high the base emitter voltage is jacked up to. For a single device running 500 milliamps, that's a pretty insane voltage. That is a small die in there. So, all right. I mean, we knew that anyway. Let's get some power going through it now. So the way I'm going to do this is back this down to 0.7, 0.8 of a volt, around there. And then the current, turn all the way down. And we're just going to look at this and we're going to turn the current up until the amperage comes up but the voltage doesn't go down. So basically around about there. I'd leave it there. So now you see we actually have the 8.2 volts across the collector emitter junction at the same time as 1.5 amps across it. This is now the safe operating area test that I was talking about. And yes, it's now getting hot without base current. So that's the collector emitter junction. Anyway, that heatsink stood up, and that's a very small device on a thick piece of aluminium. So that's got quite some time before this temperature starts getting hot on the front here. This whole bit of aluminium's got to come up to temperature before it loses the ability to quickly suck heat out of here. So this won't actually rise. It's hot, but I can hold my finger on it and it's not getting any hotter. It'll stay like that for a bit. I mean, it is slowly obviously getting warmer, but until the heatsink really gets hot and loses its ability to suck the heat out, this is going to be fine. And that's the thing. I'm just below max power, so I want it to get a little bit warm, otherwise it wouldn't be a good test. Anyway, let's have a look at these whilst that's happening. These look so convincing, the prints on them, it's actually quite surprising. I'm half wondering if these are like actually legit reproductions. You know what? Let's see what the HFE is like between them. I mean, yeah, okay, I just destroyed my Peak, but I'll order a new one, like literally in a couple of days. I'm too impatient. I'm trying to get things done and I've just screwed myself in the middle of it. I kind of need that tool at the moment because I'm about to start plotting all sorts of graphs on small signal devices and medium signal devices like, you know, TO126, TO92, TO92L for my amplifier projects. So, I mean, that's why I bought this other tester that can source more current. Because like I said, I want to really start getting back into amps like I used to be. Started getting into it a few years ago and then sort of just, I don't know what happened. Tell you one thing, it won't be happening again. 282. The reason I say let's have a quick look is because there's a lot of different types of transistors here. Some of these are going to be high gain types. Some of them are going to be really low gain types. If these all measure, you know, 160, 150, 170, 140, and nothing's outside of that, for example, it's pretty obvious what's going on, right? Okay. So we got 280, I think it was, and 140, 146. So that's a good sign. Wow. And that transistor over there is still somehow passing all of that power. I don't understand. This has really got me quite concerned because I know for a fact, like I said before, I'm not taking any guesswork here. In fact, you know what? I've got real parts I can show you guys. I'm going to show you guys some real dies in a sec. Just so you know that I know how big certain dies are supposed to be. Because this has really got me concerned, the fact that these parts have got dies that are under half the size, 216. Okay, these are different. You know, that it's so small and yet it's working. And like I said, I've looked at a whole load of reviews on AliExpress. I've found people that have sold 500 of the kit that had all the fake tip series transistors in it and that. Over 500 sold, all good reviews. And I'm just sitting here going, what? You know, something needs to be done about this. Silicon technology can't have improved that much. Seriously. I mean, you think about it, right? Power dissipation, to get more power out of something, you need to make it bigger. It's called surface area. You can only get so much power through a piece of silicon into a copper heat spreader through a bit of solder or whatever onto a heat sink. There are, what do you call it? Thermal resistances, you know? And to overcome that, all you can do is pick the best materials you've got and make the surface area wider. You can't go smaller and get rid of more. Oh, 272. Yeah, these are all different. Are they all different in the same batch? Okay, because that's something else that could be happening. We could have 146s with 200s with 300s, you know. So far, this is looking bloody promising. And I wouldn't imagine that this size of transistor to be really up there like 500, 600 some probably should be. I'll have to get data sheets. Like I said, I'm going to do a few videos on this. I'm doing little bits of research every day on this. There's, okay, 168. Hold on. The one I just tested was higher than that, wasn't it? Because it doesn't mean I can go through one pile to another and go, oh, that's 150, that's 300, that's 200. Yeah, that's good. But if there's also 150, 300, and 200 in the same thing, then it doesn't mean anything, does it? Okay, no. 150, 140. We're going to be doing a lot of stuff coming up in the future with this because I want to work out exactly what's going on. Oh, okay, that's my fault. When I say what's going on, I mean how to work out exactly which are the Asian factories making legitimate products, how to work out exactly which ones are the fakes to avoid, and how to work out what is the differences with the clones. Like, you know, some clones, here's the thing, some clones are actual copies. Like sometimes people somehow reverse engineer a die or get the secret source formula, whatever you want to call it, stolen and remanufacture dies, and they're basically exactly the same. Other clones, they literally experiment with dies and curve trace them and all that sort of thing until they get similar performance to the part they're trying to make. So, and then others just use any random die, like this, like what we were saying before. It looks like they are using a lot of tip 32 dies in different things, you know. So I want to work out, you know, exactly what's what and how to differentiate. So there's going to be a lot more coming up in these videos. You know, these transistors are going to be getting used in circuits. The reason I bought all these audio transistors is literally to put them. One of the things coming up I'm going to do is build basically a small amplifier that's got test sockets for output transistors, drivers, fast stage, current mirrors, current sources, input pairs, so that we can swap in and out different transistors and take measurements, literally. And, you know, I'll even put pots and stuff in certain areas where resistor values need to be changed to change the current source's current setting or emitter resistor values and stuff like that. I'll put pots in there and sockets all over the board, so it's like a little test board, you know. I've got some big plans coming up for this channel. And I've got some big equipment that I'm going to get too, you know. I mean, I'm going to get the Quantasylum soon. And that's where all this is going. Building amps, analysing it, all that sort of stuff, you know. And by the end of all this, I'll have better answers for you guys than all the people on YouTube that are already building amps and all that sort of thing, you know. Because I don't want to offend anyone, but I've already watched, I watch all the big channels. I've been into this for a long time. And I'm telling you now, I watched a video by the Tony guy that has this Tesla I just bought only the other day, and he had one of those little bags of transistors that say B133 or whatever on them, those little Chinese 292s, and he came to the opinion that they were legit, and I was just shaking my head, just going, wow, you know, like, he didn't even think to get a magnet and see if the legs were steel. Like, that's a dead giveaway. But anyway, so be it. I will do all the work very thoroughly. All right, so how are we going to tell, other than just testing them like this, if the dies are the correct size or not? The only thing I can think of is data sheets. Now, this could get quite annoying because I'm basically going to have to get a lot of data sheets up and read them before I find some that have got a wild difference between the two. Like, I need to find a part that's, you know, got a collector emitter current of 50, 100 milliamps and another one that's 800 milliamps. So I can pull them apart, you know, and power dissipation of one that's got, you know, 0.1 watts and the other one's like 1.5 watts, you know what I mean? So I'll go do that now, and then we'll select a couple and see what's inside them. Alright, I don't have internet at the moment. I mean, I have internet, but my 4G is not working in here. It's been a problem for like the last month now. So, yeah, don't know what to do about that. I'm not just going to go blindly smashing them open when I don't even know where to start, because, I mean, these are starting to set, like I said in the last video, it seems like the smaller ones do have a possibility of being real. You know, Tony could have been right. But I'm not too sure, you know. It's the same dodgy looking stuff that you see on everything else. Well, actually, no, it's not. Let me rephrase that. All the TO126 and TO220 devices have got totally different trademarks to what these smaller devices have got. Does that mean that they're not fake? No. It's just a different printing process for a different device, and it's probably made in a different factory, that's all. But I don't know. I mean, some of the ones I was just looking at were really convincing. I mean, you look at the marking on this one, for example. If you didn't notice other things about the package and the legs and the plastic that's sticking out the bottom of it and all that, and you just looked at the markings on that, you'd think that's, you know, good. I mean, other than the font being the same Chinese font that's on them all, it doesn't look exactly right to the naked eye. Like if I, let me go get some genuine transistors. If you look at genuine transistors that are laser etched, you see what I mean? It's just, there's something different about it. And I'm not talking about the size of the letters, because that's a bigger part. That makes sense. But it's the font and the color. You know, it's just never, it always stands out to the naked eye. So, and yes, these are legit, don't worry. Yeah, anyway. I was thinking maybe, oh, guess what? Our transistor failed. The heatsink's warm too, so okay. I'm not sure exactly how hot that got, but it can't have gotten too hot because I haven't been here for long. That's failed open, and this is, like, it's barely warm. It has started to spread out, but not all the way, so it can't have been that hot. But okay, that did fail. You know, it probably was that's amazing. That was approaching its safe operating area, because if that heatsink started to warm up and it was roughly around 10 watts, you know, it's only a 12.5 watt part. You know, say you can run it at this temperature and this wattage, or 12.5 watts and no temperature. If you run it at 10 and the temperature starts coming up, at some point these two are going to equal safe operating area destruction point, and it's going to go. So that's what happened. The thing that amazes me about that is the die in that thing is literally like a million times, well, not a million times, but an order of magnitude smaller than what it's supposed to be. And yet it literally behaved like a normal one. Now that's got me even more curious. I'm going to have to put a tip 41 on there. Let's see how these things hold up. I'm not going to pull one of my parts open again, because I showed you guys in the last 3-hour video. You can see in that video what a genuine tip 41 die is, but you know, it's a couple millimeters. It's a nice little chunk like that. It's not a speck like that. So all right, that's mounted. For this test, I've already got a warm heatsink. It's not heaps warm, but it's warm. So that's really good, because I can have this at a starting temperature, put a fan on it, and keep it at that temperature essentially. So make for a really good controlled test. So I'll get that going now, and then I'll come back. It will take me a minute to set it up, because I'm going to have to turn the power up slowly and monitor the temperature until I get it at, a steady point. Alright, I'm not expecting it to last long because I've got 14 volts going to the fan and that's ridiculously hot already. But it is doing... I'm just trying to get a little bit more voltage across it unless with the same current, sorry. It's a bit tricky. Alright, I'll leave it there. That's as close as I think I'm going to get it. And that is pumping quite a bit of power. That'd be about, close to the 65 watts. And it's running very hot. So this is, again, this will be outside of the safe operating area. Not by a lot, but yeah. By a bit. Wow, yeah, quite a bit. I'm just going to go down to 5 amps and 10 volts. Because my heatsink is quite behind on the transistor temperature. I don't know what to make of this. This should have popped. With the size of the dyno, it doesn't make sense. What the hell, let's just cook it. I mean, this isn't telling us anything now because the thing's too hot anyway. It's like I said, it's outside the safe operating area. What a trooper. How is it exactly on 6 amps it goes into saturation? I don't know. That's the one thing that sort of blows my mind a bit. And the other one did much the same thing. Talk about taking a beating. I can't believe it. There's the fan if you're wondering. Trust me, I've got pretty dry skin. I can handle the heat. That is blistering hot. The heatsink's just a really good heatsink. It's very efficient at getting rid of heat. Well, I'm going to turn that off. Let's do something else now. I was watching Tony, who I was talking about before, doing the same test I was doing when I got those dodgy 2SC 5200s, and then I got some others that I think are real, but I'm questioning it now. When I did the breakdown voltage testing, I found that with the base floating, it wouldn't pass. But with the base tied to the emitter, it would pass. I still to this day cannot find a definitive answer, because on some websites it says connect the base to the emitter, on other websites it says don't. So I don't know. But I can tell you now, this is a tip 41. Let me just have a quick look what the voltage is on this. I think it's 100. Yeah, 100 volts. Let's see if it makes it there with the base floating. I wish this tester wouldn't do that. Okay, well that's 126 volts. Unbelievable. Let me just show you something. This is supposed to be a 230 volt part. No, this isn't the one that we think's fake. Or no, it's fake because it's got a really small die. This is the other one. The ones I was going to use before I got the NJW 0302s, 0281s. I've got 1302s and 3281s as well. NJW and 2SC. But anyway, I remember doing this, and this is a PNP by the way. It didn't get to 230 volts without the base tied to the emitter, which now makes me wonder. Because remember the die was, well, that's something else I questioned. The die looked wide enough, but it didn't look thick enough. And the breakdown voltage would only pass the test with the base tied to the emitter. Let's see if that's the case. Oh. Okay. No, these don't behave like that. Oh, you know what I must have that in my memory for? Let me go put this. I'll just leave it there for now. It must have been these, the bag of hollow ones with the small die inside them. Let's see. Oh wow, the writing's so different on these. I never noticed that before. That's hilarious. Oh my goodness. The fake industry. These are those fake ones with the really small die inside them. Yep, breaking down. Yeah, 127 volts, can't go past it, you see? But 230. So, yeah, real interesting. Now, that doesn't matter because these are complete rubbish fakes anyway, but I just thought that was interesting. So, I think Tony's right. In his video, I saw him testing transistors with the base floating. I'm going to say that that's how you do it. You just have to obviously be careful to lift the base pin up so it's not near the metal that this is on, because this is the collector. You don't want to capacitively couple charge into the base pin, because you get charge carriers on there, on that junction, and it turns on. You're going to think that it's breaking down when it's not. Alright. Well, I really don't know what to say about this. Those dies are definitely way too small. Yet, for some strange reason, not only they pass their rated current, but that's 2 transistors now that I've had that for some weird reason go into saturation exactly at the maximum rated current in the data sheet. No, it's not going into saturation. Yeah, no, it is going into saturation. Because, yeah, it is. Yeah, that's really odd. I don't know what to say about that. It's almost like they are sitting there and trying to get all of the characteristics right, but somehow on a smaller piece of silicon. It doesn't make sense. And just for the record, by the way, onsemi doesn't make these in this package with the cutouts in the tab. That's the biggest giveaway if you didn't pick up on all the rest. But yeah, yeah, I'm still just as confused as I was in the first video. I don't know what these guys are doing, but it's bloody odd. I'm just glad that I'm finally uncovering this for us all, because I've spent years reading articles on audio forums, DIY forums, electronics EE forums, everything, you know, and no one's got a bloody clue what's going on, and neither should they, because how can one person, you know, and here's the thing too, I'm not trying to be cocky or anything, but look, I'm not going to deny the fact that sometimes I do have decent amounts of money, depending on how things are going in my life, and I can afford to buy a lot of components, right? Some people aren't as well off and struggle to buy the exact 8 NPN and 8 PNP that they need for their project, you know? So I feel bad for people, because not everyone can go out and just buy a shit ton of transistors and sit there for weeks playing with them and working out what's going on. I can, so I thought, well, I'm going to do it, you know? And I'm going to do it very thoroughly. And I'm going to go all the way until I've got a definitive answer what's going on, and I can say, hey, this is what you can do to buy clones that are actually copies. This is what you can do if you want clones that are not copies. And this is what you can do if you want fakes, you know? When I've got that information, I'll be really happy. Because especially now that I'm seeing these really small dies that are actually handling the current, that's too much for me. I just can't sit knowing that this is happening. Do you know what I mean? Like, please, I'm begging you guys, please, because I really want to know what your opinion is of this. Like, leave it in the comment section. Does this worry you? The fact that they are now not just faking parts, but managing to somehow seemingly get away with it, at least to a point. Like I said, I'm not saying that you could run full current through these for 24 hours a day and they'd last, but like I said before, even if they're lasting for 2 weeks now, not 1 second or 1 minute, that's a massive, massive problem. That allows people to sell it, ship it out, get it delivered. Some poor dude buys the parts, fixes guy number 2's amplifier. Guy number 2 goes home, uses it for 2 weeks, it breaks. Do you know what I mean? By that time, the person that sold the parts has got away with theft. That concerns me. And like I said, most of these parts seem to be getting bought by DIY enthusiasts and hobbyist community that they work with Arduino projects and they build little circuits on breadboards that flash LEDs and make buzzers buzz and solenoids pop, and you know what I mean? They turn a little 3-volt motor. I'm not taking the piss out of anyone. That's how you learn. I'm just saying the sad thing is they will never know that their parts are fake if they work at low current levels. So, yeah, there's a lot that's got me concerned here. I'm the sort of person that doesn't sit for this sort of crap, you know? If you do dodgy stuff and I pick up on it, watch out. Yeah, because it just makes it terrible for people, especially the people out there that are learning electronics. You know, I mean, you got to think how many people are buying these, doing their calculations. They've just learned how to calculate safe operating area and all that sort of stuff, right? And they must feel so good about learning this math. They go do calculations, they build their first thing, and everything pops. Not only the outputs pop, but the drivers pop and half the other transistors pop too. And the poor people don't know what popped first because of this crap. Do you know what I mean? I can think of so many scenarios where this is going to leave kids crying and people out money, waiting to get money again to try and buy the same parts again to only have the same failure. I can think of so many scenarios where this is going to hurt people. So if I can uncover not only what's going on with the fakes and how to detect them, how to avoid them, all that sort of thing, but where to get good copies that actually work and perform well, even better. Because one thing I've noticed reading forums, and I mean, I can speak from myself here, I try and get stuff cheap. And, you know, I can probably afford to buy more than what some people can. I've seen on forums a lot of people talking about the fact that they just can't afford to go and buy a ton of transistors from the local store, but they can't afford to buy 10 off AliExpress. So if I can find a definitive way of saying, yeah, look, these are the shops to go to, this is what the real deals look like, this is what the bad deals look like, these are the shops to not go to, you know, I feel really good in myself because I'll know that I've helped a lot of people. So, yeah. Anyway, I'm going to leave it here for this video. I don't want to pop open those devices in this video that we were looking at because I don't have data sheets for them, so I'll do that in the next video. But yeah, that is scary, very scary. That, just to remind you all, the Chinese can make that little speck dissipate 13 watts reliably. And it really is a speck. Alright, that concludes this video, but before I go, I just thought I'd show you the boxes that these transistors came in, so you know what to look out for online. Because the two listings I've noticed in common that are the dodgy clones, or whatever you want to call them, are these kits that come in these boxes. And the other listings are basically a picture with sort of a white background, and usually a whole load of transistors types just written in letters, and a picture of one of those clone devices that have the tab with the cutouts and the writing that's not correct for the manufacturer. So far, all the legit listings I've found say import, original stock. They have a picture of the item in, like, you know, original packaging, or a box that came from DigiKey or something, or it's on the tape. I don't know, they look different. I'll show you some examples in the last video. Like, I'm doing a lot of research on this and piling a lot of stuff up to show you guys, so it'll be good. But definitely avoid these. Everything in this thing is I don't know what to say. Undersized but works. I don't like saying that, but yeah, whatever. Buyer beware. Alright, I've got some more information for you guys. I did want to mention one other thing. Those tests that we're doing, we're only testing continuous current, not peak current. The peak current's double the continuous current. And even, for 5 milliseconds, I can't see them holding up. But I do have a signal gen. So, it does 70 megahertz. So I should be able to test quite a few things with that. So I'll do some calculations, and we'll most likely be doing pulse testing in the next video as well. Anyway, I just found this, well, to be honest, I've looked at a lot of different websites like this, but this website has the most biggest collection I have seen on one page. So I thought I'd give you guys a look. Let me just see if I can get the phone any closer. I don't think I can. Okay, that works. Since that works, let's do this. Alright. I think that's as much of the web page as I can get at one time on the screen. So I'm just going to start scrolling down slowly. I'm not going to read this out loud. You'll see why as I start scrolling. There is a lot here. And I'll tell you now, if you want to read it, just pause. Because as you can see, I'm not scrolling at a lightning speed. Just give it a pause. And, sorry, let me try and get, oh my God, what on earth? The freaking ads you get in America, wow. I don't think we have that in Australia, do we? Anyway, was it Joel's Garage Gear? No, okay. Alright. I'll leave that up. Some people might find that interesting. And then I guess this is the first part. Yeah, it's a bit hard to get the right bits on screen in one go, but I'll do the best I can do. Like I said, just pause it and have a read if you want to have a read. We're going to pull apart some more transistors after this, because you guys might remember when I got those fake 2SC 5200s, 2SA 1943s, that some of them had really small dies in them, and then I found some from other sellers that had big dies in them that, like I said earlier, the dies appear too thin, and I'll show you what I mean in a sec, because the other thing I noticed was some sort of white glue inside, but I don't remember it looking like this. This literally looks like someone's taken celastic, silicon, whatever you want to call it, and put the die down with that instead of it being on a solder bed or something, which is insane when you think about how hot it gets, and a multitude of things don't make sense there. But let's continue. I am confused why a lot of these are up, because oh no, he's saying these are original. Okay, I was going to say, what on earth? There's nothing fake here. But let me just find the section. I did find one on here where the guy was saying that they're real and this is a way of doing it, and there was like a piece of tape inside, and I was just like, no mate, I've never seen tape inside a transistor. Yes, here it is, attached with some kind of adhesive tape. That's No, that doesn't work. And if you think about it, the back of the die has to touch this. This is the collector. If you put a piece of tape in between the die and your heat spreader, you'd have, well, a base and emitter with no collector. So yeah, that's the thing about this. That's why I'm making this video series, couple of videos. Like I said, I want to look at everything and really go into detail, document everything I've seen, and in hopes that these videos finally put to rest any and all question regarding fake transistors. As you can see, there's quite a lot here. That let the smoke out. So I really am confused with some of this guy's claims. He's saying that these are fake. Here. Oh, wait. Oh, above. Hold on. Oh, no. These are original. That's what I was going to say, because I know what these look like, and I've just ordered some myself, and these are definitely what they're supposed to look like. That is 150 watt die. This is the old school. This is an older die technology, and this is the way the top of the die looks. Yeah, these are not fake. I'm quite familiar with that transistor and the die. Anyway, let's continue. Oh my god. I don't know. Another one. Now, there's nothing wrong with this one here on the right. Oh wait, how have we lost our translation? Sorry guys. Yeah, like you said, the transistor on the right isn't original. Okay, so this guy does know his stuff. He's correct. That's what I thought last night when I was looking at this, but I was falling asleep when I found it. So, but yeah, no, I'm happy with what I'm seeing here. This guy's like me. He knows his transistors. He's been working on things for a while. He's pulled a lot of transistors apart in his life because, like me, he wants to know what's in them. I don't mean from legit sources. I mean what fakes contain. And legit, so you can compare them, but yeah. See, someone else with the MJ15022, which is very close to MJ15033, isn't it? Or is it not? Maybe it's not. Sorry if I keep pausing very so often, even though I read this last night, because I was falling asleep, I forgot a lot of it, and I'm looking at it again now, and things are catching my attention that I'm just getting a little bit lost. My apologies. But like I said, I'd advise you guys to get lost in here too. I'd advise you guys to, if you didn't watch the complete 3-hour video I uploaded, the first video, I suggest that you go watch it in sections, because there is a lot in that video. Just like this video and just like the next video. Like I said, I'm going into this in great depth, and every single thing I can think of, I'm going to look at. The last video is probably going to be the most interesting video for a lot of people, because it's going to be based around a lot of testing. So I'm going to have 2 different transistor testers, some power supplies, some test circuits. I'm going to try and pulse test them. A lot of different things. So that's probably going to make for some interesting content. But the point of this is to look at research, look at inside devices, see what they do, everything that I can do basically, you know. I want to compare saturation voltage on them in another video too. There's just so many tests I want to do. Breakdown voltage, but we'll get there. I think we've already learnt quite a lot so far. Or I hope everyone's learnt quite a lot, because I'm trying to help everyone here. I don't want these bloody, what do you want to call them, thieves, scammers, to be getting everyone's money anymore. I would like to see the good people like LSX and CHDX and other stores like that actually sell original components, get all the business, and these bloody fakers just getting nothing. Huh. Don't do that, mate. He says he finally found the counterfeit 2SA 1943. Let's go have a look at them. He said he found them useful. I don't understand how you've used bloody fake transistors in anything. Yeah, I've purchased originals too. Oh, it looks like they do have that whitey substance I found in mine on them. Okay. So you see, it's not like that. It's totally different. We'll pull mine apart again for comparison. I've got enough of them. I'm not worried. Does he have any more? Sorry, I will go back down the bottom. That was them. Anyway, I've gone past them again. All good. Oops, gone too far. Like I said, there's a lot here. Somewhere around here I was. I've got a lot of transistors rocking up. The last couple of days I've ordered a couple of different batches, all from my preferred sellers. None of these transistor kits. All old school, new old stock. Nice, really high quality transistors, like Toshiba and KEC audio transistors, drivers, fast stuff. Yeah. So I will. Oh, and I'll have that DCA Pro 75 sorted out within about a week. So my amplifier project's still going to be happening. I mean, it was always going to still be happening, but I mean, it's still going to be happening soon. So you won't have to wait too long. I've got stuff to do in the meantime. I'm going to finish this video work on fake transistors, and then I'm going to do some more datasheet to breadboard series, and then by then everything should have rocked up and I can just continue on the amplifier. So fake STK modules, I'm sure you've all seen them before. This is not necessarily a fake, but a reproduction. There are legit reproductions that people actually make that looks quite similar to this, but also the fakes that I've seen, sometimes they are made with transistors inside, but just way smaller. Sometimes they're made with components discrete like this, and the components are too small. This honestly doesn't look too small to me. This looks like it could be oh, hold on. All right. Yeah, just forget what I said there. There's a whole transistor missing. That doesn't. That doesn't inspire faith. Oh, it's replaced with a smaller one. Yeah, no, that's not a faithful reproduction. Not by any standard. What? Never seen them. That does look fake to me. That's quite interesting. It sort of looks like someone literally just made their own design. I mean, they all look different, but I don't know. Something about that die top just doesn't. Yeah. No. Something about that's not right. You see, okay, that's more complicated structure, so it's going to look more complicated, but actually, I don't know that that's fake either. Yeah, I don't think that's fake. Maybe it is. Yeah, it could be. Maybe it's all made on one die. I'm not sure. There are transistors that have two dies. So, yeah. Darlingtons, obviously, if you're wondering. Yeah, that's what I was telling you guys. This is what I've seen. They still have these devices in them, but they're way smaller. You see, that's two devices on each thing. That's all four there, right? And then you look at the drivers in here, they're much bigger packages that have got matched transistors in them, thermally matched. Here they're just single transistors, not thermally coupled. That is fake as. Absolute rubbish. So is this. Yep. See, that's original. Yeah, that's original. No. Yep, counterfeit. Wow, that's terrible. So that's that. I hope everybody paused and got a good look at that. All right, last but not least, let's take another look at these. I've actually got another 2 or 4 batches. Like, there's 2 different numbers there and 2 different batch numbers there, and I've got another 2 or 4 different batch numbers. Now, already to note, there's a slight color difference between those 2 and those 2. I don't know if that comes on camera. Yes, it does. Good. Also, the leads are different. Those are thinner and appear different. Don't have any steel in there. Alright. Don't have re-welded leads. Oh yeah, that's something I haven't mentioned. That's another thing that they do. They salvage devices and reattach leads where they've been cut off. Oh. These are. Oh wow. These are salvaged. Yep. Leads reattached. Alright. That's interesting. Yep. They don't break off like I've been told, but I can clearly see where they joined and the effort they've gone to cover it. I can clearly see. Wow. That's quite interesting. So these must be not messed with. I wonder if these are still actually 2SC5200s or a different transistor with the leads reattached. Well, there's one way to find out, isn't there? Actually, I'm going to take this to the vise and try and pull them apart really cleanly with some heat. All right. Yeah, okay. Nothing wrong with that. And that is how it's supposed to look with the gluey stuff. You see it's not that silicon, it's that white. And look at the dye. You see how more complicated the dye looks? That's what it's supposed to look like. Now, is the heat spreader right? Yep. This isn't a two-piece design, it's just a thick piece of copper, but I'm pretty sure that's correct. Like I said, I still don't know about the dye. It looks really thin. Like you can compare it to my nail. My nails are pretty thin. I mean, let me go get another 150 watt dye just to show you what I'm talking about. Alright, I can't find the other half of this and I don't want to go pulling these apart because they're legit. But take note that when I split this, there was still at least a thicker lump of silicon than that on the heat spreader. And there's still silicon in here, which means it's, you know, it's like that thick. It's, you know, we've seen inside the tip 41, 42s and they are thicker too. Even what's left here is still thicker. Oh no, that's only a thin layer. Oh. Yeah, no, that's about the same. Interesting. Alright. Well, that one that I just pulled apart was one of the ones with the welded legs. Actually, you know something? I don't know if these are welded or just re-tinned. Let's see if I can melt this. Let me show you on camera what I'm talking about. Look at the bottom of the legs. That's not how they're supposed to look. That's how they look. Right? I'll go get some more of these. One sec. Here's another two that I found that have got really obvious signs on the legs. These are the real transistor button inside. And it is the part it's advertised as. It's just these are salvaged, cleaned up, and then new legs attached. I don't have a problem with that if they're just sold as that. I don't think I bought this from one of those reputable sellers I did mention, because when I bought the 2SC5200s and 2SA1943s, as you know, I got about 6 or 8 different lots, like half that number if you want to call the NPN and PNP one lot, but if you're referring to like the 1943s as one lot and 5200s, I've got about 8 different batches, at least 6. So I bought them from quite a few different people, so it's a bit hard to work that out, but yeah. Alright, well, That was a 5200. Let's have a look in the 1943. You know what? I'm not going to worry about it. I trust that these are what they are. I can tell looking at it. I mean, obviously anything else could be inside, but no. These are reattached legs. These are just salvaged. I'm not going to waste any more of them. What I am going to do is I'm going to see if this can be melted to expose what's underneath the leg. Because I can't tell if these have just been dipped, because this is another practice. They get old parts and they re-dip the legs. They seem really strong. They don't seem rejoined. But the legs do at the same time seem slightly different. It really does look like they cut them right at the base and joined something on there. It's one of the two. These have been re-dipped or rejoined. Yep. I can feel the join. I don't know what to make of this. Let me get some solder wick on there. Let me see if I can clean that a little bit more. Whatever that stuff is, it does mix with solder and... yeah, it does. Hold on, let me see if I can take it all off. Yeah. So that is tin. That's that sort of stuff that you can see around it that looks different. That's just a tin coating. But I don't know. It's like there is something there. But it refuses to bend off of the point that I think is a join. So you know what? I think these have been re-dipped. Let's just fix this back up. I think these have just been re-dipped. I mean, it does make sense if they were either pulled off of a board or if they were really, really old stock. The legs might have started oxidizing. They might have just sanded all the legs up and just re-dipped them, you know. I'd hope they sanded the legs first. Jeez. That's some food for thought, isn't it? Oh, God. Imagine tin coating rust. There's one way to find out, isn't there? So I swear I'm the only person on YouTube that will go this far for you guys and for myself. I think people are just too lazy. They'll take a look at something for 2 seconds and be like, yeah, nah. They don't want to really look in depth. Well, I'm getting down to nice shiny copper. And not one point did I see any signs of oxidation, so that's a little bit interesting. I'm not quite sure why they would re-dip the legs. Oh, sorry about all this noise. Having a bit of a clumsy day here. Yeah, I'm not too sure what's going on there. Just tidied that back up. All right, well, let's take 3 of these ones that have either had legs rejoined on them or have been re-dipped. Oh, that's interesting. That's a 223 batch. These are 248s. This was a 228. I've got quite a few batches of these. I don't feel like pulling them all apart, even though I've got so many. These look legit, and I've pulled a few apart already in other videos, and I've gotten quite used to the markings, the cases, the plastic they use. These look original. I mean, you can tell that half of these are quite old. Look at this. Look at that. Look how that edge is all worn down. Like, these are old devices that have been recirculated. Try and clean them up, I think, and paint them or something. Probably just clean them. Who knows? At least we still got this to check again whilst I wait for a new DCA 75 to arrive. I really shouldn't be doing this because I need to save up for my own things like teeth and bills, but I really want to get on with work, so I'm just going to fork out and buy another one. And just be very careful with it. Last night was not a good night for me. If you're wondering what I'm doing, I'm just curious how similar these all are. Like, did they get pulled from the same board? Same batch of boards, or are that and just the same batch number printed on them, or are they all completely different transistors? Actually, you know what? Let's lay these down face flat because I've been handling them. We'll just get the temperature to equalize out. I know just the thing to do this. Stick a heatsink on top of them. Alright, they've got enough thermal coupling now to keep their temperature even. $73.55. Sorry about that. That was a knock at my door. All right, so $73.55. The second one. God, I love the bloody Atlas DCA's clips. These are rubbish, these cheap ass. Fuck. 73.55. 108.58. Jeez, man. God, that's just plain annoying. 8256. I don't think these are the same batch. I reckon what they've done, they've pulled a whole load of random transistors off of all different boards, and they've just relaser etched them and either attach legs, reattach legs, or just re-dip them. They are real, I guess. Hey, oh my God! You know what? I have real 2SA 5200s. Only one of each. I used to have heaps, but I built amplifiers and what else did I put them in? There was an amplifier I built. It was some that I fixed. I had to replace outputs. Oh, power supplies. Power supplies. Yeah, and I've got 2 left. Let me go grab them. They're really old. The legs are like that short. They've been used in 100 projects, but I mean, hey, they're real. I can pull them apart and see what the die size is. I'll sacrifice this one because the heat spreader's all yucky on it. I mean, I could sand that down, replate it, and then sand that, you know. It's possible to resurface a heat spreader, but it's all good. This is more important, isn't it? Oops. Let's compare them first. Yeah, no, they're real. I don't even think I should be pulling this apart. Oh. Oh. Hold on. Well, look at that. The holes on the sides are slightly different. Ah, the markings are different on this too. Oh no, they're exactly the same. Let's just do it. I'll go take this to the heat again so we can get the die out properly. Wait, I just realised I don't need to do this. I've got a page up on my computer. Hold on. My computer's just updated itself, so I've got to log back in. Oh, great. The web page is gone. I was using the internet on my phone. Let me just have a look. Alright, I just uncovered more mystery doing research, so I am going to pop this open now. It is what it is. Yeah, it works. I don't like damaging stuff, especially if it's original, but hey, it's got a thrashed back and cut legs, so it can be a test subject. I'll go do this with heat so that we can see the die properly. Damn. Hey, what on earth? Someone said that some packages have got tape in it, and I literally said on the video, how is that possible? That makes absolutely no sense. How the hell does the back of the die make contact with that there? What? Hold on a sec. That is so odd. I don't know what to say. And that tape is over it. not under it. Like it's in between. Oh no, it's not, because okay, so the tape's put on there to, yeah, I don't know. You know what? I don't think this is tape. I think this is a glue. And it's just peeling off. And you know what I think? That's exactly what this filmy stuff is. Let's see if I'm right. Yep, it's a peelable film. This is a different type, but it's a glue that's sort of like a film. Yeah. All right. Let's see how thick this die is. There is literally nothing on there. Like I can't even see the thickness of it. So if I crack this, and this is extremely thin as well, then we know that these are all real and I don't need to worry about the dies being so thin. Oh yeah, it is. I've just gotten to the edge of the die here and I can see how thin it is, and yeah, that is quite thin. I'll just clear off a little bit more for you. And I'll bring it up to the camera and show you the edge of the die exposed. I don't know if you can tell how thin that is, but that's thin. So, okay, I'm not destroying any more of these. So they've maybe had legs reattached. I think they've just been re-dipped. I don't think they've been reattached, because I melted the tin coating and the solder. I flowed some solder into it to make it get rid of it, you know, and then moved that down the leg. And then once I did that, I ran the tip of my iron up the center of the lead to feel for that join line, and I couldn't find it. So yeah, I don't know what to say. It's a bit strange. How rugged are these dies? What's the base? Hmm? Five 552 550. Yeah, that's both the junctions. Cool. Interesting. I was curious because I gave it a bit of a twist opening it, which flexed the back plate. So I wanted to see the integrity of the silicon die. Yeah, no, these are legit. Well, that's good news. I'm not worried about the re-dipped legs and all that sort of thing. So here's the thing, right? They okay, I just found that on my floor. That must have come out the bin. They're completely going to get completely matched before I use them anyway. So, you know, boy, that is laughable. I still find it quite scary that that little blob can pass 65 watts. That is freaky. Yeah. All right, well, that concludes this video. I hope we've all learnt something, and in the next video I'll have a new DCA75. I'll have that other transistor tester. We'll pull apart some more devices, and we're going to do some extensive testing, breakdown testing, safe operating area testing, power dissipation testing, all that good stuff. Peak current testing. So stay tuned. Alright, thanks for watching. See you all soon. Bye.